Okay, let me show you the contents of this video first. First, I will explain what is the hand gesture recognition (HGR). Then I will explain the hand gesture recognition scheme using the basic image processing steps. Then I will cover the various steps of achieving this HGR. And then I will explain the DTMF, dual tone multi-frequency generation, and device control scheme. And in the last, I will explain the MATLAB code to implement this SGR and the corresponding DTMF based device control. So let's go ahead. So let me show you first what is this hand gesture recognition. Hand gesture recognition HGR is a very significant for the human computer interaction. So with the help of HGR, we can interact with the computers without any mouse or keyboard. So with the different hand and the finger gestures, we can give various commands to the computer to perform various tasks. And HGR can be a very good tool for disabled people to interact with the computers or some other machines. In fact, it can be used for the sign language. So HGR can be performed with help of the specialized hardware such as special clubs, markers, sensor, depth cameras or 3D cameras, etc. Or it can be achieved by use of image processing and computer vision from simple 2D images. The major application areas of hand gesture recognition can be such as the consumer electronics, automobiles, gaming, device control, defense, home automation, and automated sign language, of course. Now let's see the proposed HGR scheme. So first we have the image of our hand, this palm area with the fingers, which is captured by a webcam. And first step is the hand segmentation. Extracting this hand image from the background. This is done in this case with a simple binarization scheme. And in the step 2, we go for morphological image processing steps such as hole filling and some isolated object removal if there are any in this image. And then in step 3, we extract this palm area. Again, some morphological image processing operations are done in this case. And in step 4, we get the finger areas by palm area subtraction method. And then we count the number of fingers using connected component analysis. And in step 6, according to the number of fingers, we generate the DTMF tones for that number. So this DTMF tone goes to the DTMF decoder, and the DTMF decoder gives a digital output corresponding to that number. If suppose the number of fingers are 2, then we get the binary equivalent of this number like this 0010. So this goes to the relay driver, which drive some electrical appliance or device. Okay, so with help of this scheme, we can switch on, switch off, the control a particular electrical devices. So let's see this scheme now step by step. So I will take one step at a time and I will show you the input and corresponding output of each step. So the first step is the hand segmentation using simple binarization process. So this is the input image, which is the RGB color image captured by your webcam. So the segmentation is done using the simple binarization process such as the OTSU process, and we get this type of output. So your hand is segmented from the background. For efficient output, your background must be of light color, preferably the white or off-white. And if there is a uneven illumination, then the segmentation will be the poor. So lighting condition should be good. And in the second stage, this image 2 will be given as the input. Here you can see some these black shades, black areas inside this main area, and here you can see some isolated pixel groups also like this. So we have to remove these isolated pixel areas. So that is done in the second step. I mean the hole filling and the isolated object removal. So this is achieved by some morphological image processing steps. Those will be clear during the code sections. I will explain you the related code. So this is the corresponding output, and you can clearly see that all these holes or shaded areas are now removed, and these isolated pixels are also removed in this case. So your image is now perfect for further steps. So next step is the extracting the palm area. So here this is your input image, which is the output of your previous step. So this will go to the palm area extraction. So first we will go for image erosion. So that is again a morphological operation. So with image erosion we get this type of output, and this erosion is done with a structuring element of type disk. It is with a radius, let's say 50, and after this this image is dilated with a structural element again with a disk, and our radius is more, let's say 60. So after image dilation this becomes like this. So this is actually representing the palm area. And now in the next step I will get the fingers, number of fingers. So that is quite simple. So what you will do, you will simply subtract this image from this image. So when you subtract this image, obviously your finger areas will be in the output. So that is the output of this process. So here you can extract the fingers. If there are 3 finger, 4 finger, 5 fingers like this, then all fingers will come in this image 5. So this is how you could achieve the finger areas by subtracting this palm area. So the process is very simple. So logic is very simple. And now we will count the fingers. So after getting the finger areas, now we will count the fingers. So that is achieved with connected component analysis. So in the connected component analysis, this analysis gives actually the number to each pixel of a group. So this is one group. So each pixel will be assigned a number, let's say 1. Okay, and this is another group of pixels. So here each pixel will be given the number 2. So by this way you can find the number of objects in this image. So obviously there are 2 fingers here, so I'm carrying the count equal to 2. So if there are 3 fingers, obviously I will get 3, and so on. So this is how we could count the number of fingers. Now with the help of this number I will generate the corresponding DTMF tone. So let's see what is DTMF. As I said, the DTMF is the dual tone multi-frequency. So these tones are actually generated in the phones. So this is your phone keypad. So if you press any number of your phone keypad, you listen some sounds. So those sounds are known as the DTMF tones. So how these sounds are generated? Actually, when you press a key, let's say number 1 is pressed, then 2 sinusoidal waves are generated. One is of 697 Hertz and other is of 1209 Hertz. So these 2 sine waves are actually producing that particular tone. So each key is particularly identified with this pair of sinusoidal frequency. So if you press 2, you again generate 697 Hertz sine wave and 1366 Hertz sine wave, like that. So since I'm using a single hand in my image, so obviously the fingers will be 1, 2, 3, 4 and 5. Or if no finger is detected, then it will be the 0. So obviously I'm going to use only the key 1, key 2, key 3, 4, 5 and the key 0. So I will generate these corresponding frequencies. So this is known as a low frequency group and this is known as a high frequency group. So this will be the scheme. So first this DTMF tone will be generated in my laptop. So first I will count the number of fingers. So I will get a number, let's say 2 or 3 something else. So depending on the number of fingers, I will generate this DTMF tone, and then with help of an audio cable, 3.5 mm cable, I can connect this DTMF decoder to the laptop like this. So this is the audio jack of this DTMF decoder circuit. So when this DTMF tone is played, this signal will go into the DTMF decoder, and this DTMF decoder will decode that what frequencies I have generated from the laptop. So after the recognition, it can tell that which key or which number was pressed. So if I press 3, or the number of fingers are identified as, let's say, 3, then the corresponding DTMF tone will be played, and this DTMF decoder will give the digital corresponding output at the output pin. So it will give 0, 0, 1, 1 for decimal 3. So that is a binary equivalent. Okay, and these signals are now given to a relay driver unit. So here you can give the binary input to this relay driver, and some electrical equipment is connected with this relays. So you can switch on or switch off any electrical equipment just by showing your hands to the web camera. Okay, and if you want to know more about the DTMF tone, how they are generated, how they are recognized, and the corresponding the hardware detail, then I recommend you to watch my previous video, that is the device control using the DTMF signal and the MATLAB's app designer. So this video you can find on this link that is given in the description. So this video is comprehensive. You can get all the idea about the DTMF signals, okay, and the corresponding and associated hardware. And if you want to know that how the webcam can be interfaced with the MATLAB, I mean your laptop running MATLAB, then I again recommend to watch this video, because such commands will be used in the MATLAB programs in this video directly. So corresponding link that is given in the description. And now let's see the limitations of this proposed scheme. This proposed HDR is actually the very basic, and it is achieved with the basic and few image processing steps. More are of morphological nature, so therefore it is faster for the real-time operation, but however it suffers with the following conditions. So it works well for a certain distance between the camera and the hand. So very far and the very near hand can degrade the finger recognition. So that is the main problem. And second is the hand segmentation is achieved with the basic binarization. Therefore, the lighting conditions should be good. I mean, there should be the even illumination, and illumination is not even, some shades are there or background is complex, then it will be difficult to extract your palm area, I mean your hand figure. So what to do and how to tackle these two problems? These problems can be overcome with by this step. So if you can go for some pre-trained CNN, such as the deep learning, where your artificial neural network is trained for thousands of images of hand over your uneven illuminations or with a complex background, then you can extract the hand image from those complex background or in complex environment. So these two problems you can overcome by this step, but of course it will require more efforts. So now let's go for the code section. I'm in the MATLAB program. So here is the MATLAB program to implement this simple HDR process and the corresponding device control using the DTMF. So let me explain this MATLAB program. First clearing the workspace and command area, and then first declaring a webcam object cam. So here I'm using an external USB PC camera. So I'm using this command, and then preview cam. So a window will open, and where you can see that what the camera is capturing currently. Okay, how I got this name USB 2 PC camera. You can learn each and everything about the webcam interface in the video which I have just recommended you to watch in the previous pages. Okay, now we are capturing one video frame with a snapshot and then getting the size of that snapshot. And now we are initializing a video player object with a vision.video player, which will start at the location 100 on your screen, and it will have the size of this, which is equal to your captured frame. And now we are defining a variable run loop equal to true. So that variable will be used to break this while loop, which is infinite while loop. When we will close this video player, your loop will break and you can come out from this loop. So inside this infinite while loop, you are capturing the image from the camera, and this image is first converted into the grayscale because camera is capturing the color image. After converting to the grayscale, we are resizing this image to 480 by 640. So this step is required because the different people may have the different cameras with the different resolutions. So there is no need to process a very large image or higher resolution image for that. So it will slow down your processing speed. So it is better to resize all the images to a certain dimensions. I mean, this is sufficient for processing. And in the next step, your image is first binderized. So here you are doing your hand segmentation using the binderization process. Okay, so this is your hand segmentation, and after binderization, this image is flipped in the pixel values. I mean, all ones are flipped to 0, all zeros are flipped to 1. The reason is for morphological operations, we need the object of value 1, I mean of white color on the black background. Okay, but when we binderize our image, we get the reverse of it because our background is light and hand becomes darker. So hand becomes black and background becomes white. So that's why we are doing the complement of this image using IM complement. That is required for the coming steps. And now we are filling all the holes, I mean all black shades inside the main region, and we are removing the isolated areas using this opening command. So this will remove all the isolated areas up to the 10,000 pixel crop. And now we are defining the structural elements of type disk of radius 50 and 60. So they will be used for erosion and dilation. So img4e is the image which is eroded by the command imerode. So your image 4 is eroded with a structural element SE1, I mean of the disk size 50. And after that, the same image is dilated with the structural element disk of size 60. And now here we are getting the fingers. So as I said, you will subtract this palm area or dilated image from the main image. So you will get the number of fingers. So you get fingers like that. And after this operation, we see that your image is not perfectly binary. It has some -1 values. So all -1 values are now zeroed, and it is converted to the logical. It means it's a perfect binary output image. Okay, and here again we are removing some isolated pixels if they remain any in the image up to the size 5000 pixel crop. And now we are doing the connected component analysis for counting number of fingers. So MATLAB has this inbuilt command bwconnncomp. Your binary image is passed to this function. So all the detail of your image goes to this variable cc. And from this variable, with this command cc.numObjects, you can count the number of objects. So that goes to NOF. So if there are 2 areas, finger areas, or 3 finger areas, from this command cc.num objects, the number of fingers will be, of course, 3. So you get number of fingers in this variable NOF, and then converting this image to unsigned integer for display purpose, and number of fingers, which is your double format, I mean it's a number, it is converted into the string. That is again will be used for display purpose. So what I'm doing here, I'm inserting this text, I mean number of fingers, in the image. So if this is your image having the 2 finger areas, so at the top left corner I will insert this information that number of image identified is 2. So this is done by this command insert text. So it is inserting text at the 0000 location, and this is your string NOFS. That includes the count of fingers, font size 30, and this box color is yellow. Box opacity you can also control from 0 to 1, and the text color is black. Okay, and now with this command we are giving this frame to the video player for the display, and now we are checking this run loop variable, and we are checking whether the video player is on or off. I mean it is still running. If it is still running, then run loop is true and you will remain in the while loop. And if user closes this video player, then run loop becomes false and you will come out from that infinite while loop. And once you come out from the loop, this clear cam will be executed, your camera variable will be deleted, your camera will become off, and your video player will be released. But inside the loop we have to generate the DTMF tones also. So we are generating the DTMF tones corresponding to the number of fingers. Okay, so if number of fingers let's say is 2, then DTMF corresponding to the 2 will be generated, and it will be played via the default hardware of your machine. And we are giving some pause, let's say pause of the 2 seconds. So this loop will continuously run, and you can show your palm or your hand to the web camera, and it will recognize the number of fingers at the moment, and depending on the number of fingers identified, recognized, it will play the corresponding DTMF tone. Okay, so now let's see what is inside this DTMF gen function. So this function I have written, it is not MATLAB function. So this is the DTMF gen function which will generate the DTMF tone. So first we are defining the sampling frequency, that is let's 8K. This is the time vector to generate the sinusoidal waves. So I'm taking this from 0 to 2000, that means the total duration will be 2000 upon 8000, that means 0.25 seconds. And this is a low frequency group of sinusoidal waves. So I'm generating all sine waves of a low frequency group. I'm in 697 Hertz, 852 Hertz, 770 and 941. And here I'm generating the high frequency group, that is 1209 Hertz, 1336 and 1477 Hertz, with a simple sine 2 pi f upon sampling frequency into time. And now with this if condition, I'm checking the number of fingers. Okay, so if number of fingers is 1, I have to generate this sinusoidal combinations of 697 and 1209. So y is the DTMF tone corresponding for this number 1. And with this function sound y comma fs, this is your sampling rate. This is played via your computer's hardware. And if number of finger is 2, and you generate this combination. Similarly for number of fingers 3, number of fingers 4, number of fingers 5. So it is sufficient to have the number of fingers 5. Of course we are showing only a single hand. I have extended this code for all the numbers of the keypad. So I have written the complete program, so users can use this program for their other projects. Okay, otherwise for this hand gesture recognition, up to the 5 is sufficient because of the 5 fingers. But if no finger is detected, then you have to write for 0 also. Okay, so this is the end of the program. Okay, now let me show you the actual setup. So this is the actual setup of the hardware. This is your DTMF decoder. which is based on this IC 8870, and this is your 3.5 mm audio cable which is coming out from the computer, and from this cable we will receive all the DTMF tones. So suppose the number of fingers identified are 2, then here the binary equivalent 0010 will be generated by these 4 lines. So these 4 lines are going here, and this is your relay driver circuit. So here you can see the 4 relays and associated hardware, and here I have connected 4 LEDs as the load, LED 1, 2, 3 and 4 you can see. So when the fingers are identified, the corresponding binary code is generated, and then relays are actuated according to that. So your corresponding LEDs will be on or off. Now let me show the execution of the program and the functioning of this hardware. So for this I will jump to the MATLAB, and this is the program which is already written. First I will not connect this hardware, I will just make you listen the sound corresponding to the fingers identified. So let me run this program. For that I will press this run button. So this is your video preview, and this is the window which will show you the number of fingers. So this is my hand, you can see, and here you can see that number of fingers identified are 5. So that you can see in this top left corner. So this is 0, this is 1, this is 2, 3, 4 and 5, and you can listen the corresponding DTMF tone also. Okay. So now I will attach my hardware, and I will show you that how LEDs are turned on and off with these number of fingers. Okay, this is my hardware setup. You can see this is the DTMF decoder, and this is the relay driver circuit, and here are 4 LEDs as the load. This is the 3.5 mm audio cable which is coming out from my laptop. This is my laptop, and this is the webcam, okay, which is attached to my laptop, and this is the white background on which I will place my hand. So now let me execute this program. So I'm pressing this run button. So the 2 windows are open, you can see on the screen, one for input and other for output, showing the fingers. So right now there is no hand, so obviously you are seeing a 0 count. Now I will place my hand, just showing only the 1 finger. Okay, so this is my hand, you can see only 1 finger is shown. So see the status of LED, it is showing the binary equivalent 0, 0, 1, only 1 LED is on. Now 2 fingers, so you can see the identified fingers are 2, and the second LED is on, that is showing the 0, 0, 1, 0. Now 3 fingers, so 3 fingers are now identified, and the binary equivalent you can see in the LED status 0, 0, 1, 1. Then with the 4 fingers you can see 0, 1, 0, 0. Now I am placing all 5. So you can see 0, 1, 0, 1 here in the LED status. So this is how you can control your devices just by showing the hand to the camera. Okay, so it's quite simple interface and fast, and it is also very interesting. So hope you will try this. I hope that you have enjoyed this video and learned a lot of new things. So I really thank you all for watching this video. Please like this and share it to the maximum. Goodbye.